Hi everyone, how are you guys doing? Good, awesome. So I'm the last thing between you and your lunch, so it's better pay attention. My name is Amin from AY Technologies, and I'm going to talk about psychology, and mostly about psychology of estimation when it comes to software development. So a little bit about me. I'm the founder of AY Technologies. It's a software development agency in Vancouver. We help startups when they want to build their MVP version 1, version 2. But I'm also the co-founder and CEO of Craver Solutions, which is a mobile app platform for restaurants. As part of AY Technologies, the way that we help a lot of entrepreneurs understand software and understand how they can build software is that we help them with their software development planning. And we do that as part of a workshop. We call it the Roadmap Workshop. But this workshop is highly influenced by definitely our experience in software development, but also psychology. And that is basically what I'm going to talk about today. So let's see. I have everything here. So one thing that I've found a lot of time we have issues with is the clash between the speed and quality. So when things start, like it seems that, especially recently, the biggest KPI that we are measuring our progress with is the speed of development. How fast can you release this feature, or how fast can you release your platform? And that is causing issues in the quality, which means that we're going to deliver something that has bugs, that has low quality, and going to be failure for our projects, for the company, and a lot of cost to the company. So the question that I wanted to figure out, like this was the biggest question, we make mistakes when things are moving fast, and we all know that. But why do we make these mistakes? Because if we know if things are moving slow, we are making the right decision, that means we know, in our brain knows the right answer. Why does it give us the wrong answer when things are moving fast? So that's when I started reading this book, Thinking Fast and Slow by Daniel Kahneman. So in the book, Daniel Kahneman describes how our brain works and how the different parts of our brain are in charge of different types of decision making. And he also describes many cognitive biases that we have in our brain and how they affect how we behave. And the result of that is the issues that we see with our errors. So, how many of you have seen this before? Perfect, everyone. So if you've seen this before like me, you know that the two lines are of equal length. But yet, every time that I look at this myself, my eyes are telling me the line in the bottom is shorter. It doesn't matter that I know, my eyes are telling me the line in the bottom is shorter. But what happens is that because I know that the two lines are equal, my brain is overwriting what my eye is telling me and saying, no, the two lines are equal. So this is one of those type of cognitive biases that Daniel Kahneman talks in the book about, and these are type of cognitive biases that I want to talk about and how it affects how we estimate software. So you've heard me say Daniel Kahneman's name a couple of times. Let's introduce him. Daniel Kahneman is a psychologist known for his work on the psychology of decision making and on psychology of judgment and decision-making. He's the founder of the field of behavioral economics, and he's the Nobel Prize winner in economics, and actually the only psychologist who ever won a Nobel Prize in economics. So he's a big shot in psychology. And part of his work was on planning fallacy. In 1979, Daniel Kahneman and Amos Tversky, they coined the term planning fallacy to describe plans and forecasts that are unrealistically close to best case scenario, which I'm pretty sure rings a bell on a lot of projects that we do day to day. Those things that they were supposed to go perfectly based on what we thought it would happen, and then something unexpected happens. But he also mentions that these plans can be improved by consulting the statistics of similar cases. So it seems that what's happening is that we are having issues with planning in cases that are happening over and over for us. And there are a couple of different examples on this, and I'm going to go through this. But basically, what's happening is that we are making these mistakes over and over, and we have data on it. So the question I want to answer, why we are making these mistakes again. So let's go through a couple of examples. This is an example I love. This is about the Scottish Parliament building. In 1997, the project started with an estimated cost of £40 million. By June 1999, the estimated cost was rose to £109 million. In April 2000, the legislators requested a cap on the estimated cost of the project, and the contractors came back with £195 million. The estimate rose, they demanded final cost in November 2001, came back with £241 million. The estimates rose twice in 2002, ending the year at £294 million, and 3 times more in 2003, ending at £375. You see the trend. And if the project finally was completed in 2004 with a total cost of £431 million. That is more than 10 times the cost. And you might say, well, that's government. These things always happen in governments, and you're wrong. Something as easy as kitchen renovation. In a survey in 2002 in the US, they figured out that, so this is the result of the survey. The estimated cost of a kitchen renovation in the US is about $18,000, which is a very small amount in comparison to the millions of dollars that we were talking about the previous project. But the actual cost is more than twice, more than $38,000. And if you think that, well, it doesn't happen in software, you're wrong again. Actually, there is a page in Wikipedia, you can go and find it, list of failed and over-budgeted custom software project. So just go and have a look at that. And then another example of that, healthcare.gov, couple years ago it happened. And the estimated cost of that project, $95 million. The actual cost, $1.5 billion. More than 15 times as much. Now, this is not to blame these projects or people who worked in those projects. Actually, I know a couple of people that worked in healthcare.gov, and they are very competent people. I myself have these type of issues, and I consider myself competent. So the question that I wanted to figure out the whole time is that why do we make these big mistakes? We have the experience. What's happening? So why this is happening, in order for me to tell you about this, let's start with the brain. So in the book, Daniel Kahneman describes the 2 systems that are at work in our brain, and they're working simultaneously. Many psychologists give these systems different names. Daniel Kahneman used the name System 1 and System 2, and I like that because it's non-descriptive. System 1 is fast, is in charge of intuitive reactions and instantaneous decisions, and it governs most of our daily life. The System 2 is in charge of deliberate type of thinking involved in focus, deliberation, reasoning, analysis, complex math problem. And usually, we identify ourselves with our System 2, with the part that is making decision, analyzing everything. But in fact, it's the System 1 that's making most of our daily decisions. If you want to compare the 2 systems, System 1 is automatic and quick. System 2 is lazy and slow. System 1 takes little or no effort to work, and System 2 takes energy. You feel it when you're solving a hard problem. You feel the energy that it's taking from you. And it uses mental focus. System 1 is on all the time, and you can't turn it off. System 2 is off by default, and you have to wake it up to do something. So what's happening is that these 2 systems are creating cognitive biases for us, because System 1 is up all the time. So I want to show you 3 cognitive biases that I think are very important in software estimation. And these are, to me, is a part of the reason we are making the mistakes. And then we'll talk about what are the things that we can do to make it a little bit better. So the first one Let me see what I had on this one. Okay, this is an important thing. System 1, this is like the most important part of System 1. You can't turn it off. No matter how much you know these two lines are equal, when your eyes are seeing that, your brain is making the decision that line in the bottom is shorter. The only reason you can say the two lines are equal is that your system 2 is waking up. It knows, because you know the two lines are equal, it knows you're about to make a mistake. So it wakes up and overrides the system 1's decision. So you cannot turn off system 1. And that's why it's important to understand and be aware of these cognitive biases. But let's start with force 1, which is what you see is all there is. What this is saying is that your brain gives different weights to the information that it has available and to the information that it's missing. So what your brain uses for making a decision is the information is right there and not the missing information. And also, your system 1 is looking for the coherency in a story, not necessarily the truth. So if the story is coherent, your system 1 is going to say, assume that it's true. Example of that. So when you read this sentence, will Mindy be a good leader? She's intelligent and smart. Without thinking about it, the answer comes to mind, yes. If I just change the two adjectives to corrupt and cruel, the answer becomes no. And your brain is now waiting to ask, give me more information so I can make a good judgment, is making that decision for you. So this is the force 1. What you see is all there is. The force 2 is prediction by association. And this is something we can call the curious game of Tom W. So assume that University of British Columbia takes 1,000 graduate students each year, and this is the distribution of people. So 28% business management and marketing, down to 5% in computer science. If I ask you, if we have a student, Tom W., what's the likelihood of him being in any of these fields, in any of these areas, you will tell me, well, the most probable one is the marketing because it's 28%, and computer science the least likely. Right. So now let me give you another piece of information on this. So the following is a personality sketch of Tom W. written during Tom's senior year in high school by a psychologist on the basis of psychological test of uncertain validity. Tom W. is of high intelligence, although lacking in true creativity. He has a need for order and clarity and for neat and tidy systems in which every detail finds its appropriate place. His writing is rather dull and mechanical, occasionally enlivened by somewhat corny puns and flashes of imagination of sci-fi type. He has a strong drive for competence. He seems to have little feel and little sympathy for other people and does not enjoy interacting with others. Self-centered, he nonetheless has a deep moral sense. Now I'm going to get back to you with the same question. What is the likelihood of him being in any of these courses at UBC from 1 to 6? Who thinks he's in computer science? Who thinks he's in engineering? Just show of hand, please. So I gave you a piece of information, and I told up there it has uncertain validity. So although we should have completely disregarded this piece of information and go with the base rate, our brain tries to replace the question of how likely is for him being in any of these fields with how coherent the story is of Tom W. given this information. We're not looking for data at that point. We're just looking, does it make sense? And it makes more sense based on our biases for him being in computer science or engineering than the marketing or business, because we are not looking for the data. We're just looking what makes sense, right? So this is the second force, prediction by association. The third force, anchoring. And you might have heard of anchoring before, but let's start with this question. Who knows exactly what's the percentage of African nations in the United Nations? Show of hand. I thought so. So nobody knows that by heart, because it's not a piece of information that for any of us, it's really important to know. Now, Amos Tversky and Daniel Kahneman ran a study in the University of Oregon, which they brought in graduate students, they asked them this question, and before they answer, they asked them to turn a wheel of fortune. They rigged the wheel of fortune to stop only at 10 or 65. And this is the result. The people who saw 10 on the wheel of fortune guessed 25% on average, and the people who saw 65, they guessed 45% on average. This is anchoring. So what this means is that our brain, when we don't have the answer, looks anywhere for a clue. And although all those people knew that the number that you're seeing on the Wheel of Fortune has nothing to do with the percentage of African nations in the United Nations, their brain still used that number. And so if I see the 10, I know that their number probably is higher than 10. So I adjusted, but I just adjusted so far, and I get to average of 25. The same for the 65. When you're anchored on that number that is completely unrelated, you adjust it, but you go just so far. So this is the third force that I want to talk about. But let's go, I have just a little bit of time left. So let's go to what does it mean when it comes to estimating software, and what are the clues that you're about to make a mistake based on one of these cognitive biases. So what you see is all there is happens when you hear, usually is about to happen when you hear something like, oh, we cannot do that. We cannot get more information. That will slow us down. That means that you're about to make a mistake. Or just give me a ballpark estimate. Like I don't want really the exact estimate. Just give me a ballpark. Or when you hear, I can't wait until we have all the details. I just need to know something right now. So that means that you're about to make the mistakes. Now, cognitive biases, one more time, we can't turn them off. Right? So it's just about identifying when we are going to make a mistake and figure out, okay, what can we do to make that better? So usually, more detailed user stories, they help a lot, and we all know that. But this is about like, why is it important to have more detailed user stories? Definition of ready and done, usually what they make is that when you don't have those definitions, that data is not there, so your brain is not counting them into the estimation. But when they're there and they're empty, at least your brain is looking at missed information. It knows that there are some missing information that I have to keep into account. Same thing with the acceptance criteria. What they cover usually is those corner cases that will not come to your mind when you don't have them. And if people ask you for a ballpark, give them a range. Estimating in range is really good when you don't have enough information. It will save you a lot of headache afterwards. So the second force, prediction by association, is a lot harder to notice. But usually, from my experience, it happens when you are estimating multiple tasks in a row, and you stop looking at the data, and you look at the coherence instead. So the best thing that you can do is to use data as the outside view. A way that I've seen this been done and been successful is to compare actuals with estimates. So to collect the actual time that it took to finish a story and collect as well as the estimates. And then over time, you can create a database of data. So you can collect the data that will tell you, for example, if you want to do a user story that is related to API, you're going to be off by 30%. And that's going to be always there, so you can adjust for that. The same thing, you can do it for similar projects, for similar tasks. Anything that you can collect with data can help you get away from the prediction by association or make it better. And anchoring usually happens when you hear something like, I think we should be able to do that in 1 month. What do you think? Right? Or do you agree that we can do this in 1 sprint? When you ever hear a number and then a question about your opinion about it, you are anchored on that number. And no matter if that's deliberate or just a mistake, that's happening. So tools to use. Planning poker, great tool to use. One step. That it makes your estimation better. You can go one step further and estimate things separately before the meeting. Because even the planning poker inside the meeting, when you're going through that, the first number, the first estimate, gonna anchor the second estimate. Same thing happens when you're doing a lot of things in a row. So you can, if you estimate all these small stories first and the harder stories later, you're gonna be anchored on those small numbers. So what you can do, you can randomize the order of the estimation as well. These are like tools that you can hopefully make it better. You can't remove the cognitive bias, but we can just get better at that. So that's another thing. But since I'm running out of time, to conclude, know your cognitive biases. These are things that we have to live with, and we cannot change them. But knowing them, then we know when we are going to make a mistake. Then identify them and adjust your estimation accordingly. It's all about data, and use data as much as you can, because there always is a project or task that is similar to that. There's no project that is completely unique, so you can use data. If you don't have any data right now, you want to use that, just go and just Google for what's the average overcost time or overtime for all software projects. Apply that. That's a good first step. But then as you collect more data, then you can use your own data to make that more accurate. And with that, here's my contact information. I can answer some questions right now, but if you want, you can send me more questions and we can chat more. I will be around for the 2 days as well. Thank you. Okay, any questions?
Yeah, the book was written in 2011, so it's been 7 years now. So at the same time, we have the BRAIN project that is running in Europe, is running in America. We have the Allen Institute for Brain Research close in Washington. So when I heard you talking about these things, I think, well, what is the actual research after this guy and after this book? What is the current step, right? How this has evolved and what new discoveries or maybe things that seems to be right but are wrong, right? And we're trying to Google that I couldn't find anything. So yeah, just a question.
So the question is that the studies are old, what happened after that? So there are a lot more studies on this, and you can find them. I highly recommend reading the book, because the book is basically a long book of studies after studies about cognitive biases in general. And one of them is the 1979 planning fallacy, but there are a lot more cognitive biases that are there. And the fact is, it's all about the cognitive biases. Like, the cognitive bias is a field that people are researching a lot, and when you know about them, then you can try to see how they apply to our field or to any other fields. I hope that answers your question.
Well, but what I'm going to do is I'm going to Google cognitive bias and actual state of research, and then try to compare what he says with what actually is happening.
That's good.
Thank you.
How do you reconcile the conflict between providing an accurate estimate and a competitive bid?
So I'll tell you what I do usually. Sorry, repeat the question. How do you reconcile providing an accurate estimate with competitive bid? The thing is, a competitive bid, if it's not an accurate estimate, it's gonna put the company in loss, right? So actually the two, they're not against each other. They're very related. If you want to have a competitive bid, you have to have an accurate estimate, right? And like the way that we do it at AY, we spend a lot of time with any of our clients before they become a client. So we actually go into details on understanding and spending that time making sure that we are not making too many mistakes. Then we look at our collective data, okay, we usually underestimate things by 20, 30%, add that estimate on top, and now we have something that will be more comfortable with.
So your Scottish Parliament example, they got paid, right?
They got paid.
Just a question.
No, but this is like, they got paid. So the question was about the Scottish Parliament and if whether they got paid. Yes, they did. But the question is like, the mistake is happening, somebody's paying for it. Sometimes it's the company, sometimes it's the government. In the more private cases, like maybe the company gonna go out of business. The question that I wanted to, or that I'm trying to find the answer for, or find some answers to, is that why do we make these mistakes? If we know why they're happening, we can try to figure out how to prevent them, right? And how to get better at it.
I guess my point is, I think probably people are using these things intentionally. Like, you can use a cognitive bias like that intentionally to essentially appear to be bidding low, but not actually be appearing to bid low.
So I should repeat that. Yeah. So people might use these cognitive biases intentionally, and that is true. But like inside the company, like a product owner doesn't want to get a low bid only for the sake of that. Like you want the company to be successful. Just look at it from like the smaller like scale things. You want each of those things to be successful. Maybe when it comes to government, they're using that, they're abusing that, but it's not always the case.
It's something you can get away with once.
It is something that you can get away with probably once or a couple of times, depending on the the industry. But if you guys want, we can chat more about it, or maybe we can have an open session on that. That's running low. Okay, thank you very much.